So how it is possible? I'll immerse in a some bath where the temperature or like a sink, whose temperature will be 40 degrees Celsius. Okay, now 40 joules of heat is what power I'll push through this end. Okay, there's a thermal conducting rod we have, and the ice at 0 degree. What is the time taken for the ice to melt? Are you able to see this? Many mechanisms will come here. Area of cross sections, let it be A1 and A2. Okay, there's a one rod. I think at least say anything you can ask you. Just stick on to the basics. Nothing is there. So like a sir, what do you mean by that rod? Heat flowing. You assume similar to like a water flowing. So it's like a L-shaped pipe, no? So if the water enters at left end, so what happened to that water? A part will move horizontally, a part of water will flow, and the remaining part, what happened, will flow here, will enter like this, no? And as this heat is absorbed by this, it will start melting. Let m be the mass of the ice. What is the temperature of ice? 0 degrees Celsius. What to do? Okay, from here, what happened? From left hand, 40 joules of 40 joules per second, the heat will be supplying. This is like a some sort of source, you can say, which will supply constant heat. It will supply the heat at constant rate. So I'll add up the question. A thermal power of 40 joules per second is fed at K1, and the right end of this rod maintained at constant temperature 40 degrees Celsius. Find the time taken by whole ice to melt. What is the time taken for the whole ice to melt? So here what actually happens here is it will receive H. Let it receive H2. From here what happen? H amount of heat will flow. From here the thermal power, say H1. Don't write H equal to H1 plus 2. H plus H1 is H2 here. If you, okay, if you want to write 0 again, if you write no, you'll get confused. So I'll do one thing. H naught I'll write. So what is H naught? Heat received by the ice, the thermal power received by this, because they say this at 0 degrees Celsius, this at 40. So the thermal power, if this rod were not there, if I don't supply it, okay, it will flow like this. No? If this is not there, then it will flow. I'll take superposition. Means when both heat is supplied and is at high temperature, the thermal power in fact will flow like this. So therefore, what is H naught? H naught should be equal to H plus H1. What is H naught? H naught is a thermal power that is needed to melt ice. MLFT. H is what we know. H1 is, what is H1? You write it. K1A 3L by 4 by So what is that one? 40 minus 0. So here this will be 40 plus 4160 K1 A by 3L. Solve for T. Anybody objections or no sir, something wrong? Still you have a chance. Okay, fine. Is this okay, H1, what I'm writing? See, in this particular rod, due to this, there'll be flow of heat. Due to this 40 degrees, there'll be flow of heat. So this 40 degrees between 0 and 40, I'm writing, no? So what is the total thermal resistance? It will see the resistance of this plus this one. Effective resistance. So what is the effective? They're in series. So that should be taken. I think I have to do correction here. Again, the series parallel idea, we are forgetting. So what is H1? H1 should be 40 minus 0. If you want, I'll write it 45. So that 40, 45. Okay, take it. Somebody is telling what is that 40. Okay, this will be by the effective resistance. What is the effective resistance? I should add up these two. So 45. What is the effective resistance? Length of this rod 3L by 4 K1A. Length of this rod L by K2A. Okay, able to get this one. What is R? R is the resistance between 45 and 0 degrees. Or how much of resistance the heat flow will see? Resistance of this rod plus this rod. But sir, what about this? You are not taking anything. Directly, I know how much of heat current. No, I know H. Directly, I'll put 40. But you are not taking on this side. A1 and A2 are okay, same area. Okay, yeah. I'll make changes. So you do have some tricky questions of this kind. Here, what is the idea we applied? Conservation of energy principle. What all the heat the ice receives will be due to this temperature and also due to the heat energy supplied at left end. So together both it will flow like this. So therefore first this equation H plus H1. What is H? Directly we know it. How much of this H1? Okay, this will be, you have to take it like a, these two rods will be in series. The R is what? Very important. So solve for T, will get the required answer. Getting, you do have different set of questions of this kind, huh? Be careful. Okay, I think now we'll stop here. So tomorrow I'll continue from here. I gave assignment, SC Orma, you try to do first and try to, after this, you can SC Orma and also do parallelly other books. But don't do only one type of problem. You have to work out different set of numericals.